Okay, so we're going to do some examples related to the last video. We're going to look at drawing some mechanisms and predicting some products. All right, for our first example, we want to draw the mechanism for the given reaction. So we have a ketone being reacted with a primary amine, and so this is going to give us the imine as the product. So I think it's helpful to think about this as occurring in two steps. So first we're going to create the intermediate, that's sort of the equivalent of a hemiacetal, and then we'll finish it off in the last three steps by converting that intermediate into the final product. So the first three steps in the mechanism are the same as the first three steps in the mechanism for forming a hemiacetal, except they're in different orders. So we start with the nucleophilic attack and then follow that up with two proton transfers. So we'll start with the nucleophilic attack. Now we're going to end up with a negative oxygen atom and a positive nitrogen atom. All right, we'll follow this up with a proton transfer where we're going to protonate that negative oxygen atom. And the acid, the proton donor, is going to be the ammonium equivalent of our nucleophile. All right, in the second proton transfer, we're going to remove one of the hydrogens from the nitrogen to give us that neutral intermediate. Okay, so this is sort of the halfway point. The next thing that we need to do is we need to pop this OH off. But of course, OH is not a good leaving group, so we're going to protonate it, and then it can come off as a leaving group. And these next two steps are identical to the two steps in the acetal formation after we formed the hemiacetal. All right, now that we've converted that OH into what is now a good leaving group, it'll come off. Next we'll go to the oxygen. The lone pair from the nitrogen will become a double bond. hydrogen now has 4 bonds, so it'll have a positive charge. And then for the last step, we just need to have a proton transfer. To give us our neutral final product. Okay, in this case, we want to predict the product of this reaction. So I again have a ketone and a primary amine. They just happen to both be part of the same compound. So when I form the imine, essentially the nitrogen is going to take the place of the oxygen here. And then when we have the imine, we have the carbon-nitrogen double bond that we'll have, and then we've got the R group coming off. It just so happens in this case, the R group coming off is going to curve around and be connected to it. So I think in drawing this, the easiest thing is to number the atoms that are going to be part of the cyclic ring, and then we can kind of go from there. Right? So the nitrogen is going to be part of the ring. And it's going to connect to this carbon atom. And so I'm going to end up with a 6-member ring. So I have a 6-membered ring. And when I think about the numbers of the carbons, right, I have and the nitrogen as part of the ring, 3, 4, 5, 6. And so the nitrogen took the place of this oxygen, so there should be a double bond between the nitrogen and carbon 6. Switch back to black here. And then there should be a methyl group coming off carbon 3. And then there should be an ethyl group coming off carbon 6. And so that is going to be the major product of this reaction. All right, so this is asking us to draw another mechanism. In this case, we have a ketone being reacted with a secondary alcohol. So we're going to make an enamine in this case. So rather than having the carbon-nitrogen double bond, because this nitrogen has too many R groups, it didn't have enough hydrogens, we had to pull a hydrogen off one of the neighboring carbon atoms. So rather than ending up with a double bond here, we end up with a double bond between 2 carbon atoms. Now, this mechanism is going to be identical to the mechanism that we drew for primary alcohol. It's just the last step that they differ. And so the only difference is in that last step, rather than pulling that hydrogen off the nitrogen atom, we're going to pull the hydrogen off one of these neighboring carbon atoms. So then the first 3 steps to get us to the intermediate are going to be nucleophilic attack, proton transfer, proton transfer. So we'll start with the nucleophilic attack. Pi bond becomes a lone pair on the oxygen. I'm going to go ahead and draw the 2 methyl groups. Of course, that nitrogen has a positive charge. The first proton transfer, we're going to protonate this negative oxygen. And then in the second proton transfer, I'm going to get rid of that H on the nitrogen to give us a neutral intermediate. All right, now just like last time, the next 2 steps are to get rid of this OH. So first I'm going to protonate it to turn into a good leaving group, and then it'll pop off as a good leaving group. So the leaving group comes off, lone pair on the nitrogen becomes a double bond. All right, now, when we had the primary alcohol, the primary amine that was our nucleophile, we still had an extra hydrogen on here, and so we would lose that to get to our neutral product. This doesn't have any more hydrogens, so it's got to come off one of the neighboring carbon atoms. The carbon-hydrogen bond becomes our double bond, and then move up those electrons there to be a lone pair on the nitrogen, giving us our neutral final product. Okay, so in this case, we have a ketone being reacted with a secondary amine. And so what we're going to end up with is the nitrogen is going to take the place of the oxygen, and it'll have the two R groups coming off. Those R groups just happen to be connected to one another. And then rather than having a carbon-nitrogen double bond, the carbon that's being attacked by the nucleophile and one of its neighboring carbons will end up with the double bond. So our product the nitrogen replaces the oxygen, and we'll get a double bond between the carbon of interest and one of its neighboring carbons.